I'm going to go through this question in three different ways. They're all going to require us to find essentially where this point is here. Because here's the logic. If we can find the area of the whole square, and then we find the area of, say, this triangle here, which is going to be a quarter of the whole square, so we can subtract it. If we can find that point, then we can find the height of the triangle on the right. We've already got the base, so we can work out that area, and we can subtract it from the quadrilateral. So that's the aim. So here goes. Method one. This is actually how I did it. I just quite like this approach. I never really see it being used, but I think it's a good one. So I want to find this point here. I decided to use straight line graphs to help me. I decided to call this the origin, 0, 0. And I'm going to say that the square is 2 by 2. Remember, we're only interested in the fractions, so we can make it whatever we like. You could call it x if you wanted, but just to make life easier, let's use numbers. So then this will be 1 and this will be 2, and I'm actually now going to find the equation of UR. Well, it's going to be, there's a gradient, it's going along 2 and down 1, so it's going to be minus a half x plus 1. And then if I take a look at PV, that would be y equals, well, the gradient is now minus 2 because I'm going along 1 and down 2, so minus 2x plus 2, and I can set these equal to one another. A half x plus 1 is equal to minus 2x plus 2. That makes it 3 over 2x equals 1, so x is 2/3. And then y is going to equal, which I could put it back into one of them. Also, there's going to be symmetry going on, isn't there? So y has got to equal 2/3 as well. But if we just check it, we'd get minus 4/3 plus 6 over 3. We're going to get 2/3, yeah. Because, yeah, there's a line of symmetry with y equals x, actually. So I didn't need to do all of that. But I've got it. I've therefore got the height. So, right, that means the area of the whole thing is 4. If I now minus that triangle that I spoke about, I'm going to be minusing 1. It's a half times 2 times 1. And I just then need to minus this red triangle, which has a base of 1. We've now just shown that its height is 2/3. So it's a half times 1 times 2/3. That's 1/3. So I'm going to get 3 minus a third, which is 2 and 2/3. I can write that as 8 over 3. So finally, the fraction of the area I've just found this purple bit, that's what the 8 over 3 represents. So what fraction of the area of the square is the area of the quadrilateral? It's going to be 8 over 3 over 4, which gives us 2/3. My other two methods are just going to give me slightly different ways to get that point in question. Okay, method two, similar triangles. So I can see that there is a triangle here that is 2 by 1 if I go with these dimensions again. And then I'm going to create another triangle in red that looks like this. Okay, so I've got to try and work this out. So I might say that this length here is x. But because of the symmetry of the problem, I can see that this is an equivalent triangle, and that is also x. And this length here is 1, remember? So this bit is just going to be 1 minus x. Because s to u is also 1. Let me just say that again. We've got the dimensions of the purple triangle, 1 by 2. I've got this similar triangle in red. And then I've just said that the base is x, and I've used the argument that this is also x over here. That would mean that this whole amount is going to be 2 minus x. But then I'm minusing 1 from that because I only want this little bit, so I'm going to get 1 minus x. Okay. So now I can say that 1 minus x over 1 is equal to x over 2. I'm just using scale factors of similar triangles. For example, if this was equal to 4, then my scale factor would be 4 over 2. It would be 2. It's twice as big. But it's x over 2 times as big. I mean, I know it's going to be smaller, but yeah, it's just going to be a fraction. Cross multiply, 2 minus 2x equals x. So 3x is equal to 2, x is equal to 2/3. And once we've got that, we've got, again, the height of this triangle, and we're sorted. Last method. This is the quickest method, but it requires a little bit of knowledge about medians of triangles. So it's in some ways it's like the one that now I've like encountered this in a few problems. I'm kind of like looking out for it. Um, but yeah, beforehand I wouldn't have been. So I'm just gonna create, you have to realize to do this, create a new triangle, PSR, and then spot that actually U to R is a median of this blue triangle. A median is when you go from an angle to the opposite side such that you have a midpoint. And this is also a median. P to V is a median. And there's a little fact that says, I'm not going to prove it here. I've proven it in a different video. I think it was a paper 2007 or 2008. Have a look up about it. But basically, the medians divide each other into the ratio 1 to 2 or 2 to 1. So this here is worth 1 part, and this would be worth 2. And what that then means is this distance is necessarily going to be a half of this distance here, or a third of the distance overall. So because the distance overall is 2, I can just say that it's going to be a third times 2 and get 2/3. Wow, look how quick that is if you have that little fact. And from that, you just do exactly the same steps as before. So don't rule this one out. Don't think, oh, I don't like that method, because I have seen Senior Maths Challenge questions that literally require you to use this fact, that you're splitting it into the ratio 2 to 1. So yeah, good to read up about it. There's lots of interesting little facts about the median. In fact, I'm going to share one last one with you. I only found out myself recently. Okay, you might be thinking, I knew this when I was, much younger, but okay, I only learned about it recently. So if you draw all the medians in, then they all intersect one another. I'm not going to prove that here, but that does happen. And you create 6 triangles and they all have the same area. Okay, that is also pretty cool. I mean, sorry if that was an anticlimax to this video, but yeah, you can see that some of them are necessarily going to have the same area because, for example, the 2 at the bottom, right, they have the same base and they have the same perpendicular height, so they have to. It's less obvious that, say, this one here and this one here would, but you can make some nice arguments about it. Again, not going to do that here. That's not really the purpose of this particular question. I've already been talking about 3 different methods, but look into it. Look into how some interesting geometrical properties of the median. Well done.